Welcome back, guys. In this video I'm going to be making a flasher. A flasher is a circuit that comes on and off by itself without human intervention in the operation. So by itself it will be going on and off repeatedly. As you can see on the screen, we are going to be needing 2 transistors, 2 capacitors, 2 100k resistors, 2 1 kilo ohm resistor, and 2 light emitting diodes. So the transistor, let me introduce you to this transistor. Okay, the transistor is C1815 transistors. We're going to need 2 of them. Both of them, they are the same. The capacitor is the capacitor is 16 volts, 47 UF. Both of them are the same. And this is a 100k resistor. The color band is brown, black, yellow, gold. That is from the right hand side. Brown, black, yellow, gold. That is the 100k resistor. We're using 2 of them. And this is the 1k resistor that we'll be using 2 of them. The color code is brown, black, red, and gold. That is from the right. Brown, black, red, and gold. And this the LED, light emitting diode. And this is the popular 9-volt battery to power the circuit when it is done. Alright, like I told you, it's going to be a flasher, and I don't want to take much of our video time, so I'm going to make it stepwise. Each soldering, I may need to pause the video at some moment so that the video will not be unnecessarily long. So I'm placing the two transistors. Okay, to start, this is the C1815 transistor. This is the emitter, this is the collector, and this is the base. So I've made it that way. I had to bend the legs. So the first thing to do is to connect the 2 emitters together. Emitter of the first transistor to the emitter of the second transistor. That's the first step. Connect the 2 emitters. Yes, I've connected the 2 emitters. I've connected them together. I used a soldering iron. To do that. So after the first step, the second step will be to connect the LED to the collector of the transistors. So I'll connect the cathode of the LED to the collector of one transistor. I'll also do the same thing for the other part. The reason why I like this circuit is everything is actually in pairs, like 2 LEDs, 2 transistors. So the cathode to the collector of one, the cathode of the second LED also to the collector of the second transistor. So the LED has been connected. The next thing I'll do is, so after connecting the LEDs, the next thing is to connect the 1k resistors to the LED. So the 2 1 kilo ohm resistors will be connected to the other end of the LED, just like this. Yes, just like this. The 1 kilo ohm resistors will be connected to the LED, the other end of the LED. So after connecting the 2 1k resistors, the next thing I'm going to do is to connect the 200k resistors. I'm going to connect it to the base of the transistor, just like this. So like I said, the 100k resistors, I have to solder them to the base of the 2 transistors. As you can see, everything appears in pairs. Everything is in pairs. So just keep following the connections. Okay, after soldering the two 100k resistors, the next thing I'm going to do is to connect all the ends of this resistor. I'm going to connect them together and solder it. So that's what I'm going to do next. I'm going to connect the ends together and solder it. Okay, after connecting all the ends together, I think the remaining two parts are the capacitors. So the capacitors will be connected between the collector of one transistor and the base of the second transistor. Don't forget, the collector is where we connect the LEDs here. So we're going to connect one end of the capacitor to this, the negative end that has this white stripe. The other end does not have this end that has white. So we're going to connect it, then extend it to the base of the second transistor. So I'll show you what I mean. Okay, this is what I mean. I soldered it to the collector, from the collector of one transistor to the base of the second transistor. So I'm going to do this same kind of connection for this one too, from the collector of this one to the base too. So, and I want you to observe something at this point. If you notice, this leg is not directly connected to this collector. I connected it here. The reason is because, okay, like I was saying, I did not connect the leg directly to this collector. The reason is, anywhere along this line has become the collector, because I've connected this to this, so they are all the same. If I need to make any connection with the collector, I can make it anywhere along this point. So let us continue with the circuit. The next thing is to connect the second capacitor from the collector of this second transistor to the base. So I'm going to make the connection around here. I may not necessarily touch it, but it has become the same thing. Okay, I've connected the second capacitor, and the circuit is completed now. What remains is to connect power supply to the circuit. So I'm going to solder a wire to this point and to the end of these resistors to the battery. This is where positive will come in, and this is where negative will come in. So negative will actually come in through the emitter of the transistors that has been connected together, and positive will come in from this end where we have the resistors meeting. So I'm going to solder two wires quickly. So this is the positive on the battery, so it has to face the other side. So this is the negative. Now connect the negative to this point and the positive to the other point. Okay, I've soldered the two wires, and the next thing is to connect the power supply. So this is the minus and this is the plus. Okay, so I'm connecting the plus like this and the minus like this. Okay, look at our flasher circuit. You can see one LED comes up, then it goes off, and the other one comes up. So that's what we expect of this flasher circuit. You see, they are changing their position. Actually, the other one goes dim. It's not completely off, but at least you can see the circuit in operation. Just connecting the battery can make it do like this. So I've intentionally made the flashing to be slow so that we can observe it. We can actually make it faster, but the component selection that we have used is to make it slow so that we can observe the transition. So this circuit is actually called Astable multivibrator. Astable multivibrator. If you want to know the theory of how it operates, you can just put it on Google. It will bring it out and you're going to see how it works, how to calculate the frequency. I intentionally choose these component values to make it slow. So guys, this is our first project and I want you to try as much as possible to repeat this by yourself. If you have your LED doing the way my LEDs are doing, you can show me the video. And if you are able to get to this point, I will have to congratulate you. You have passed the first step, because constructing this circuit like this in a naked form is actually putting our technicality into test. This is what I'm trying to say. You see, all the connections are naked and I've managed to prevent them from touching each other. You observe very well, the ones that are not to touch each other are not touching each other. So if there's a touch somewhere, the circuit will not behave as expected. So there are better ways of constructing circuit, but I just decided to do this first example so that you will understand that building electronic circuit, it's all about connecting them in the right way. So I've shown us all the connectivities, all the connections, and I think you should be able to do the same. You should be able to repeat this project. So this is our first project. Every theoretical thing about it will be posted and you can read up about the theory. Thank you. Alright guys, this is still our first project, but there's a quick modification I want to do. You know, the LEDs are interchanging, but they are not completely going off. If you observe, this one is bright, then it goes dim, then the other one becomes brighter. So I can modify this circuit so that I may achieve a result whereby the LED will actually be turning off. I can achieve that by connecting a 1K resistor across the LEDs. This is what I mean. I will put this 1K resistor on the LED. I'll make sure it's connected. I'll put it across the LED. If you observe, this LED will go off completely now. You see, it's off completely. Although the other one is still doing dim, but this one is going off. So I'll do it for the two LEDs. I'll connect a 1K resistor across them. Look at the connection. I hope you see the 1K resistor. So I'll quickly solder it on the two LEDs. Okay guys, so after connecting the 1K resistors across the two legs of the LED, we can observe that the LED is actually going completely off, unlike before that it's dimming. So it depends on the effect you prefer. If you like the completely going off LEDs, you may want to put the 1K across it the way I've done. And if you like the dimming LEDs, you may decide to leave the 1K out. So the circuit is working on its own now. The battery has been connected permanently on the circuit, and there's something I normally do when I complete circuits like this. I like to leave them to run indefinitely. I just want to see them working. It gives me more inspiration. So guys, if you can get to this point, you have done a great job and I must commend your effort. So what I'm going to do next, the next project will be how to construct this particular circuit in a professional way or in a more advanced way, not using skeleton kind of connectivity. We're going to be using actual boards. We're going to be using circuit boards. And don't think doing this circuit is too simple for you. Please try as much as possible to do it, because there's some things you're going to learn on this simple circuit. For example, you may practice your soldering skills by constructing a simple circuit like this. You may practice how steady your hand could be, because in the real sense you are going to be handling way more components in the future. You might be designing a circuit that has more than 300 components. So you have to just start small. learn small, because you may think this circuit has no use apart from flashing. My brother, this circuit you're seeing could be turned to an inverter. Yes, an inverter. All we are going to do is to change the frequency of the oscillation, then connect it to power MOSFET, then that will be an inverter. In fact, I will make sure I show you how to convert this simple circuit into an inverter. I think when you've heard that this circuit could be converted to an inverter, a working inverter, you should be eager to construct it, either like this or in a board way. Just try to construct it and let it operate like this. Thank you.